Greetings, math friends. Let's look at doing the derivative of sine. To do this, we're going to do it by definition. We want to do the limit as h approaches 0. And down here, we're going to have h. We will have sine of x plus h minus the sine of x. In the numerator here, we are going to need to apply the sine angle sum formula. Over to the side here, we're going to look at the sine of x plus h is going to be equal to the sine of x cosine of h plus the sine of h cosine of x. We're going to substitute that in there. All right, so now we have three terms here separated by a plus or minus, so we cannot just factor out a single term even if we had matching angles, which we do not. We have sine x over here, we have sine h here, and we have sine x over here. We can commute these and then factor out a sine x over there. There's only a cosine in each of these terms. If we try to factor that over here, we would end up generating a tangent. If h goes to 0, this will end up being 1 minus 1, which is 0, so that term's 0. This over here will give us a 0 here, so this is going to 0, and then the denominator is going to 0, so we have an indeterminate form, so we need to continue to work on this process. Rewriting this so that we break this into two separate fractions, we're going to have the limit as h approaches 0 of sine x times cosine of h minus 1 over h plus the cosine of x times the sine of h over h. Now, this is essentially a constant. This is a constant. We're going to have to rely on essentially a theorem that says that we can take this constant out through the limit and just look at the limit of this, and likewise this. We're passing the limit through here. So something you might have proved in a calculus course, but more likely it's an analysis course where we can move these limits around. We are going to look at the sine of x times the limit of h approaching 0 of cosine of h minus 1 over h plus the cosine of x times the limit as h approaches 0 of sine h over h. And then each of these would be a theorem in themselves, which we won't prove here, but you can prove previously, so you can use them as lemmas to help you with this proof. This one is going to 1, and this one is going to 0. So using those lemmas or theorems, we're going to say that this is sine x times 0 plus the cosine of x times 1. So this product will be 0 plus the cosine of x times 1, which will just give us back the cosine of x. And some of you have probably already memorized that the derivative of sine is cosine. So to actually show this by definition, we essentially have to pull in theorems to assist us with this. Something that allows us to move this limit through this summation and product setup here. And then when we look at these individual pieces that we have in parentheses, this and this would be separate theorems as well. If you are interested in how this happens by definition, this is a beginning introduction to how that works. To be more thorough, we would have had to have previously demonstrated the limit passing through these here as a separate theorem, and then each of these pieces being a theorem, or if you wanted to prove it all together, it would get fairly bulky, but that would be another way to actually write that proof out. Many times you're just told to memorize that the derivative of sine is cosine, and then you don't have to go through any kind of derivation process. Hopefully this has been interesting to think about how we get this, which is probably taught as a property or a theorem in itself. I hope you find some mathematics in your world to enjoy. Cheerful calculations.